Hey everyone, it's James again.
And Jerry!
And as promised, we're back here with a brand new video. So, one of the things you might have not known about us is, back in the day, we used to have a science show. Whoa! And believe it or not, we were digging through the old archives down here in this creepy basement of Jeremiah's, and, we found some clips of it. So, without further ado, let's roll the clips. Warning, the characters and ideas expressed within this video are completely fictional and the results of our own stupid imagination. Except for the outfits of the chemistry teacher, which are completely parodied off our own teacher. Use common sense when following the instructions of the show. After watching this video, keep your girl crawl off your computer monitor. You have 7 days left to do it. Your discussion is advised. I don't know about you, but I think science is just about, the coolest thing in the world. I mean, think about all that science has managed to accomplish. That's why Jeremiah and I, my friend, made the James and Jeremiah Science Prevails show to show all of you viewers out there all of the cool things that science can do, such as... See that? That's science. That's science too. That sticky stuff is science as well.
Whoa!
All of those science things, my favorite scientific thing in the world is balancing chemical equations. So, to give you a better idea of what that looks like, let's step right into the chemistry classroom. Let's go! Here at the James and Jeremiah Science Prevails show, we're all about helping young students reach their full potential and learn all about the amazing parts of chemistry. Let's see if today we can find some young student in need of assistance to help teach the wonders of chemistry to. Oh look, I think I see one there. Hello there, young man. Are you in need of some chemistry assistance today, perhaps?
I don't know, number 6, please leave me alone.
Number 6, you say? Whoa, let's take a look here, shall we? Well, what exactly seems to be the problem here, young lad?
Alright, well, sodium carbonate reacts with hydrofluoric acid to produce sodium fluoride, carbon dioxide, and water. And I have to balance the reaction equation and figure out what kind of reaction this is. And if 3.5 moles of hydrofluoric acid reacts with 6.5 grams of sodium carbonate, how many moles of sodium fluoride is produced? And I have to find what is the mass of the excess reactant that did not react.
Wow, how nifty. Let's get right to it, shall we? Let's see what we have here, shall we? So, we are first told that some amount of sodium carbonate reacts with some amount of hydrofluoric acid. And when it reacts with this, it creates some amount of sodium fluoride, which would be NaF, along with some amount of carbon dioxide, CO2, and finally, it also produces some amount of good old H2O. Let's take a look at how to balance this, shall we? First of all, looking at this, I see that we have 3 oxygens over here, 3 oxygens over there. So that doesn't seem to be too much of a problem. Just kind of looking at this casually, I notice though, here we have 2 NAs, and here we only have 1. So that means we're going to have to put a 2 right there, and have 2 NaFs right over here. If we have 2 sodium fluorides, then that in turn means that we have to have 2 over here to balance out the Fs. And with that, I put a 2 there. Other than that, looking at this equation, nothing really else seems to be out of the ordinary, so go 1, a 1, a 1. Just checking everything because we always like to be safe. 2 NAs, 2 NAs. 1 carbon, 1 carbon, seems pretty good there. 3 oxygen, 2 oxygen plus another oxygen, so we are safe there. 2 hydrogens, there's our 2 hydrogens, and finally, 2 fluorines, 2 fluorines. And that means we have a balanced chemical equation.
Professor Riggy, what kind of chemical reaction could this possibly be?
Well, looking at this here, we see what appears to be at first a double replacement, right? Because you have your sodium and your fluorine that upon reacting in the products becomes sodium fluoride. But then this carbonate here and this hydrogen don't really follow that same pattern, except they kind of do. What we have here is a very tricky sort of situation that we like to refer to as acid-carbonate reactions. In this situation, first we have a double replacement. In this case, the sodium and the fluorine, and then the hydrogen pairs with the carbonate. But then after that, a decomposition occurs, in which the hydrogen and the carbonate break apart to form our CO2 and our H2O. According to our good friends at boundless.com, when acids react with carbonates, they produce a salt, carbon dioxide, and water. And this is one of those situations. So what we have here is actually an acid-carbonate reaction. That was part A of problem 6. Balancing the chemical reaction equation and discovering what type of reaction this is, which again, this is an acid-carbonate reaction. But now let's look at part B of problem 6. If 3.5 moles of hydrofluoric acid react with 76.5 grams of sodium carbonate, how many moles of sodium fluoride is produced? Well, first, I'd like to start with the first thing we have in our equation here, and that's the sodium carbonate. So we're told that 76.5 grams of sodium carbonate are being reacted here. So we want to get it over to this. So what do? Well, first we take our sodium carbonate and we're going to divide it by the molar mass of sodium carbonate, which, referring to our handy dandy periodic table here, we discover that that is 83 grams. And this is converting it to moles. Next, what we want to do, now that we have it into moles, is use our molar ratios. That means we look at the ratio of sodium carbonate moles to moles of sodium fluoride, which is a ratio of 1 mole of sodium carbonate for every 2 moles of sodium fluoride. And this will end up canceling out our sodium carbonate and giving us our sodium fluoride on top, which we want. The final step we're going to take, just because I like to do this, instead of leaving it in moles, I'm going to put it into grams. And to do it, what we're going to have to do is multiply by the molar mass of sodium fluoride, which we discover is 41.99 grams over 1 mole. Now, what does that equal? Well, we can cancel some stuff out here, right? Cancel out that. Cancel out that. And once we do all of this canceling, what we're going to end up leaving ourselves with is, using our sig figs, of course, that we have 77.4 grams of NaF, sodium fluoride.
But Mr. Riggy, that says 3.5 moles of hydraulic fluid acid. It needs to be in grams. What the heck do I do about that?
Well, right you are. So that was our sodium carbonate, but now let's take a look at the hydrofluoric acid. So here, instead of being told that we have grams of hydrofluoric acid, we're told that we have some amount of moles of hydrofluoric acid. So let's still write out what we have first, right? So that's 3.5 moles of hydrofluoric acid. Bam, right there. So now, because we're already in moles, we don't have to use this mole conversion factor that we used up top. That's already been done for us. But we still need to do the rest of this. So let's continue moving on. Again, we're going to keep in mind our mole ratios. Canceling out the hydrofluoric acid, we want to put that on bottom, which means that we have 2 moles of hydrofluoric acid on bottom with our mole ratio. And again, the same amount of sodium fluoride on top, which is 2 moles of sodium fluoride. And now we're once again going to be converting this to grams so that we can compare the two. And we can use the same grams conversion factor, molar mass, that we multiply by. So that's 41.99 grams over 1 mole. And then, when you refer to your nice Casio calculators or TI calculators, you can go and find out that in the end you have exactly 146.97 grams of NaF, except we want to remember sig figs, so we're going to put an approximation just to keep in mind those sig figs. This is approximately 150 grams of NaF sodium fluoride, and there you go. That is not what this question is asking for. This wants to know how many moles of sodium fluoride is produced. Well, let's think about this here. So, in terms of limiting reactants and theoretical yields, which one of these, sodium carbonate or hydrofluoric acid, is going to run out of materials first when producing sodium fluoride? Well, looking at this, yeah, as Jeremiah just so
Oh!
there we go. This one, just like in an episode of Dora, this one is going to run out first because we can only produce 77.4 grams of sodium fluoride with our sodium carbonate, whereas when we have our hydrofluoric acid, we can produce up to 146.97 grams of that. So indeed, it appears that sodium carbonate is our limiting reactant, and because of that, our theoretical yield will be 77.4 grams of sodium fluoride. That's not exactly what this question is asking for, is it? No, it's not. This question wants to know the number of moles of sodium fluoride that is being produced. So to finish answering part B, we're just going to perform one more simple calculation here. And that's going to be taking our grams of sodium fluoride, which, as you can clearly see right there, is 77.4 grams sodium fluoride, and converting it back to our moles. And to do that, we just simply multiply by one simple conversion factor, dividing by the molar mass right there. And then, once you use your handy-dandy calculator, you will find that you actually have 1.84 moles of sodium fluoride that are produced using this chemical equation.
But Mr. Professor Riggy, we still need to find what is the mass of the excess reactant that did not react.
Well, right you are. So let's finish off this entire thing by answering what the mass of the excess reactant that did not react in this equation will be. So, as we have determined, this is the total amount that we can make, or mass amount. So, to get the amount of hydrofluoric acid here that's not reacting, we're going to take this number and subtract this number from it. So, pull out those calculators, everyone, and take 146.97 and subtract 77.4. And when you get that, get a good shot of that right there. 69.57 grams of NaF are not reacting with the hydrofluoric acid. So that's what we're going to write down right over here. 69.57 grams of sodium fluoride. So what do we want to do with this? Well, we want to get it back to hydrofluoric acid here because that's what we're trying to find. The amount of it that did not react. So, going back to those handy conversion factors of ours, let's first bring it back to moles by dividing by molar mass of 41.99 grams, and then using our reverse mole ratios, whereas here it was 2 moles of sodium fluoride over 2 moles of hydrofluoric acid, instead we're going to have 2 moles of hydrofluoric acid over 2 moles of sodium fluoride. And finally, for our last conversion factor, which we didn't actually end up using up here, is we want to get this back to grams of hydrofluoric acid. And we're going to use our periodic tables once more. Look at that color-coded beauty. And find that the molar mass of sodium fluoride is 20.06 grams, which are put over 1 mole. Do some simple calculating once more. And you find that the amount of sodium or hydrofluoric acid that did not react is 33.15 grams. And there you have it. It's that simple.
Thanks, Mr. Riggy, for making chemistry so easy.
Oh, we're always just so happy to help young students learn and grow and expand their knowledge and horizons, you know? Well, thanks for tuning in this week to the James and Jeremiah Science Prevails show. Join us next week when we're going to perform a live dissection on Jeremiah Capsner when science prevails.
Wait, what?
Oh, dang it, I forgot that was in there. He's completely fine, folks. Don't worry about that. Anyway, I mean, you never know what you're going to find in the basement of Jeremiah's house, am I right? Pretty weird stuff. Anyway, moving on. Thanks for watching, everybody. Thanks for tuning in and sharing that special moment with us. It's kind of a trip down memory lane. And anyway, thanks for watching. Subscribe, leave a like, comment, all that fun stuff. And yeah, see you in the next video. Peace out.